All right, let's take a look at the opener for 3.1. It says, given a line and a point, how many lines will go through our point and be parallel to our line? Remember, one of the things we're going to go over and review today is to be parallel means you have to have the same slope as that line. Well, if my line is going horizontal, the only way for me to draw that line is to draw another horizontal line. So essentially what I want to know is how many lines are going to go through this point right here that could be a horizontal line. And my answer is only one. There's only one line that can do that. All right, the note packet starts off with taking a look at just some prerequisite skills, some terms, and just doing some algebra skills again, just to kind of review some things that you should be able to do. The first question just wants you to fill in the blank. It says adjacent angles share a common what? Well, there's actually two different things that adjacent angles share. As a quick reminder, adjacent angles are angles like 1 and 2 right here. All right, to be adjacent angles, they have to share two things. They have to share a vertex, and then they have to share a side also. So they're going to share this side right here. That's what it means, common side. That's what it means to be a set of adjacent angles. The second one says two angles are blank if the sum of their measures is 180 degrees. If two angles add to 180, the term we learned in chapter 1 is we call those angles supplementary. Now, numbers 3 and 4 both deal with the same diagram. They say M is the midpoint of AB, and then find AB. Well, if M is the midpoint of AB, that means the left-hand piece and the right-hand piece have to be equal to each other. In other words, 5x minus 2 must equal 2x plus 7. So there's our equation to solve. We subtract 2x from both sides. So 3x minus 2 equals 7. Then we're going to add 2 to each side so that 3x equals 9. And finally, we'll divide by 3. So we get x to equal 3. If x is equal to 3, we can take our 3 and we can plug it in. So we have 2 times 3 plus 7 over here. We have 5 times 3 minus 2 over here. In each scenario, we end up with MB to be 13, AM to be 13. So AB, which is what they asked for, when we add them together, we get 26. Same idea for our second one then. So number 4, once again, M is our midpoint. So AM will be equal to MB. 4Z plus 1 will equal 6Z minus 11. Right? So subtract 4Z from each side. 1 equals 2Z plus 11. Oh, I'm sorry, not plus 11. Minus 11. And then we'll add 11 to each side. So 12 equals 2Z. And then we divide by 2. We get Z to equal 6. Taking our 6 and plugging it in. We have 4 times 6 plus 1, which is 25. 6 times 6 minus 11 is also 25, giving us the length of AB to be 50. Now, in number 5, 6, and 7, they just have two lines intersecting. And the key here, they want you to remember two things. First off, that vertical angles are equal. So that 38 degrees is also going to be the measurement of angle 2. Right? Second thing they want you to remember is the ones that are next to each other, they're going to have to add together to equal 180 degrees. So angle 1 will have to be 142 degrees. Angle 3 will have to be 142 degrees. Because these angles here have to add together to equal 180 since they're next to each other. In number 6, same idea. Opposite angle or vertical angles are equal. So angle 2 would also be a right angle. And then angles 1 and 2 have to add to 180. So angle 1 would be 90, angle 3 would be 90. In number 7, since I have the 135 degrees, angle 2 is vertical to it. So it would also be 135 degrees. And angles 1 and 2 form a linear pair. So angle 1 would have to be 45 degrees, so they add to 180. Angle 3 would have to be 45 degrees, so they add to 180. The last two problems deal with sketching a diagram. First one says they want you to sketch QR being perpendicular to WX. So there's my line QR. To be perpendicular to it, there's my line WX. To make them perpendicular, you have to put the little right angle marking. That marking is going to have to be there. So the next one then is lines M and N intersect a point P. So draw yourself a line M. Draw yourself a line N. Does not matter how they look or where they intersect. As long as that intersection, this point right here, you call it point P. All right, getting into our terminology then in chapter 3, we're going to talk about some parallel lines, perpendicular lines, skew lines, things like that. Looking at what parallel lines are coplanar lines that never intersect. Now, you cannot just look at something and say that they'll never intersect. We're going to be looking for markings on them. To show that lines A and B are parallel, we're going to look for those little arrow markings to be on there so that we can say that A is parallel to B. If I also wanted to talk about C and D being parallel, then I need to double up on the markings, right, if they're in the same picture. So that's what parallel lines will look like. They will never intersect. Now, skew lines likewise will not intersect. The difference is, when you look at skew lines, they are non-coplanar lines that never intersect. It's kind of like if you had a line drawn on the ceiling and then a different line drawn on the front wall. Those two lines would never intersect each other. However, they are not parallel lines either. So that's what skew lines would be. We'll also deal with parallel planes. Parallel planes are something like the ceiling and the floor. They're two planes that don't intersect, the front wall and the back wall. Right? That's what it means to be parallel planes. And then your last term for the day is known as a transversal. What a transversal is, essentially, if you have two lines that are drawn, no matter what they look like, a transversal is the line that will come in and intersect both of them. This is what a transversal would be. It is a line that intersects two or more coplanar lines at different points. Let's take a look at example 1 then. Example 1 says, dealing with this diagram, says, think of each segment in the figure as part of a line. Which lines or planes in the figure appear to fit the description? So A wants to know what lines are going to appear to be parallel to AF. So here's my line AF that we're going to be looking at. They want a line parallel to that will go through point E. Well, to be parallel to it, we're looking at this line here, EJ. The second one now wants us to be skewed to it and contain point E. Well, line EA obviously intersects it. EJ, we just said, was parallel to it. That leaves us then with line ED. Line ED is the line that is skewed to line AF because they would never intersect. However, it is also not parallel to it. C wants to know which line appears to be perpendicular to AF and contain point E. So once again, we're going to be coming from point E, but now we want to appear to be perpendicular to AF. So that would be line EA. Now the last one, there's a little bit of an error if you're reading the notes. Whoops. If you're reading the notes, they want to know what plane appears to be perpendicular to plane FGH. Somehow this was supposed to be an H and this was our G. I made a little mistake, I guess, on making that. I didn't pay close enough attention. So which plane appears to be perpendicular to that back plane? Well, we're looking at this front one here. To name a plane, keep in mind you want to name 3 letters that are on it. So we'll name it plane. We'll do BCD. You can pick any 3 points you wanted to on it. Next idea is what's known as your parallel postulate. A parallel postulate was basically what we went over in our opener. If there is a line and a point not on the line, then there is exactly one line through the point that is parallel to that given line. So if I have my line L, and my point P. I can only draw one line, being this line right here, that is parallel to line L and also goes through point P. Right? That's because they have to have the same slope. Likewise, there's only going to be one line that is perpendicular to it also. If there is a line, so we have our line L, and a point not on the line, so there's our point P, then there's only going to be one line that can go through my point and be perpendicular to line L. And that's this line that's drawn right here. Right? And that's exactly what this theorem or this postulate actually means. Let's take a look at our example then. It says, name a pair of parallel lines. So for parallel lines, you're looking for the arrows. Which two lines have the arrows on them? Well, that would be lines AB would be parallel to CD. As for the ones that are perpendicular then, perpendicular lines, we're looking for a right angle marking. So what two lines intersect to form the right angle? That is AB is perpendicular to, and then that would be CA. And then the last one wants to know our lines AB, which is this line right here, and line BC. Are those two lines perpendicular? Once again, perpendicular, you're looking for the little right angle marking. There is no right angle marking. So you cannot say that those are perpendicular lines. Now, the other thing we're going to talk about today deals with that transversal coming through. When that transversal comes through, there are four types of angles that you need to concern yourself with. The first one is known as corresponding angles. They are called angles that are in the same position. Notice how if you pick this grouping up and you lay it on top of the grouping on the bottom, the 6 and the 8 would overlap each other. That is what it means to be in a corresponding position. You are looking at two lines, and that transversal, when it comes through, is going to create two different intersections. You're going to take something from the top intersection and compare it to something from the bottom intersection. Corresponding angles are angles that are in that same or corresponding positions. Alternate interior angles are two angles that are going to lie in between your two lines. So there's my lines A and B. My angles have to lie on the interior of them. They're lying inside, but on alternate sides of that line. So that angle 2 is on the right-hand side. My angle 8 is on the left-hand side. So they're on alternate interior angles. The third one then are your alternate exterior angles. So once again, look at your lines A and B. Notice now if they're going to be alternate exterior angles, we want to be on the outside of those lines. So we're outside up top and we're outside on the bottom. But since we are going to be alternate exterior angles, notice angle 4 is on the left, angle 6 is on the right. So they're on those alternate sides. Then the last one that's there are those consecutive interior angles, which I accidentally have slid up here somewhere. There it is. Consecutive interior angles. Once again, we're back to the interior of my two lines. So there's our two lines we're looking at. We want to be inside those lines now. Consecutive means that we are going to be on the same side. So since angle 2 is on the right, angle 5 is also on the right. So those would be consecutive interior angles then. Take a look at example 3. Example 3 wants you to identify all of those types of angles. They want you to identify your corresponding angles, your alternate interior angles, your alternate exterior angles, and those consecutive interior angles in the picture that they give. So there's the picture we're looking at. First one they want are your corresponding angles. Corresponding means they're going to be in the same position. Remember, we want to take one from each grouping. So here's my first grouping, There's the second grouping. Corresponding basically means if I were to pick this set of angles up and drop them on top of here, which ones would overlap each other? So angle 1 is on the top left. Angle 3 is on the top left. So they would be corresponding angles. Angle 2 is on the top right. Angle 4 is on the top right. They would be corresponding angles. Angle 5 is on the bottom left. Angle 7 is on the bottom left. They would be corresponding angles. And the last set, angle 6, is on the bottom right, and angle 8 is on the bottom right. So they would be corresponding angles. For B wants you to find your alternate interior angles. So we want to be inside your two lines. So we're coming in here. I want one set from here, one set from here. So if I pick angle 2, since we want to be on alternate sides of my line, angle 2 is on the top, angle 7 is on the bottom. Angle 6 is on the bottom, angle 3 then is on the top. Remember, you want one angle from each vertex that's there. For C wants you to find your alternate exterior angles. Now, once again, alternate exterior. Now we want to be outside your two lines. So there's the two lines. To be on the outside of them, we got 1 and 5, 4 and 8. So if you pick angle 1, since it's alternate exterior angles, angle 1 is on the top, angle 8 is on the bottom. Angle 5 was on the bottom, angle 4 is on the top. Your last set then are what they call your consecutive interior angles. Your consecutive interior angles, we're back to the interior. So there's my two lines. We've got 2 and 6, 3 and 7. To be consecutive interior angles, if I pick angle 2 is on the top, I also have to pick angle 3 because it was on the top. Angle 6 was on the bottom. Angle 7 was also on the bottom. Consecutive means they're on that same side. Now, the other part then says that if the measure of angle 1 is 37 degrees, so the measure of angle 1 was here, 37 degrees, find the measure of angle 2, 5, and 6. So those are other angles we're looking at. Angle 6 was vertical to it, so it had to be 37 degrees also. Angle 2 was a linear pair, so it would be 143. Remember, those linear pair have to add to 180. And then angle 5 was vertical to angle 2, so it would also be 143 degrees. Your last question says classify the pair of numbered angles. 1 and 5 would be corresponding. 2 and 7 are alternate exterior angles. 4 and 5 are alternate interior angles. Right? We need to be able to identify these because as we progress here, these certain types of angles are going to have certain relationships that we need to make sure we know about. Right? And that's going to be the key as we start here. Here's your homework tonight, pages 150 to 151, numbers 11 to 15, and 18 to 32.